Hi students, welcome to Preliminary Chemistry and the water topic. This is video number 18 on calculations involving precipitation reactions. Now in the last couple of videos we've been having a look at how we make use of the formula C equals N on V to perform calculations involving involving the concentration of certain types of ions in solution. Also to calculate the concentration of a particular solution from a starting point when we say have some solid and we dissolve that in a certain amount of liquid in order to form a solution. Now precipitation reactions are kind of the reverse. We start with solutions, we have a certain number of ions in solution of known concentrations, and then we form a precipitate. Now we can weigh these precipitates, but we can also do calculations to determine whether or not we actually have a mass of precipitate that we were expecting from the theoretical or calculated value. This involves both of the same equations again, the C equals N on V and number of moles is mass over molar mass equations that we used before, but usually this time we're going to work it the other way around. So let's see if we understand this better with an example. If we look at a question where we have a solution of silver nitrate, a 50 ml, which is a volume, of a 0.1 molar concentration solution of silver nitrate reacted with excess sodium chloride in solution. Now we should start to get to the idea that sodium compounds and all nitrates are soluble. So sodium nitrate is soluble and therefore is not going to be a precipitate. So the precipitate that we're going to have is the other two, which is the silver chloride. And the questions that we're likely to be asked are things like, can we calculate what the mass of silver chloride will be in this situation? Now there's one other very important thing that we need to be aware of here, and that is this idea of excess. Now excess simply means when you see the word excess, what it means is we add enough sodium chloride for all of the silver nitrate to react. So it is possible that we may still have chloride ions in solution, but we will have pulled all of the silver ions that were present in this initial solution out as a precipitate. So that's the assumption that we're going to make. So what are the important steps to solve this particular problem? Well, the first thing we need to do is to write a net ionic equation for this process. We need to eliminate the spectator ions. So initially we'll only have the silver ions. We'll also have the chloride ions, and we're going to be forming the precipitate silver chloride. So we need to make sure that we write this in an equation and that we balance that equation. Once we've got our equation, then the mole ratios will be obvious to us because the equation will be balanced. It'll tell us what the mole ratios are. Then we use our C equals N on V formula to calculate the number of moles. So in this case, N equals CV. Remember, your name is the most important part of your CV. So an easy way to remember that formula, or at least another way. From that, we work out the moles of the silver chloride precipitate. So we just use the mole ratios to do that. So the number of moles of silver ions related to the number of moles of silver chloride. Then we need to calculate the molar mass of the precipitate. And finally, we use the formula number of moles is equal to mass over molar mass. Or in this case, because we're after the mass is equal to the number of moles multiplied by the molar mass. And that will give us our final mass for the precipitate. So here are all those steps again, but just this time mostly completed for you. So you can see the first thing we need to do is write our net ionic equation. Our net ionic equation eliminates the sodium and the nitrate ions, so we just have silver ions, chloride ions forming silver chloride. You'll notice that the numbers that are not present are the number 1. And we assume that if there's no coefficient in front, that it's just a 1-to-1 ratio, which in this case it is. Then we use our formula, N equals CV. We know that our volume is 50 mils, so we need to convert that to litres. So we have moles per litre, so that's 0.05 litres. And our concentration is 0.1. So therefore the number of moles is going to be 0.1 multiplied by 0.05 0.05, which is 0.005 moles. Okay, now that's what we had from our initial concentration of silver ions. So that was present for the silver ions. And then this is the same number because the mole ratio here, I should put that here, mole ratio is 1 to 1 here, 1 to 1. So the number of moles is going to be identical. The molar mass of the silver chloride is going to be 107.9, and again you want your periodic table to do this, 107.9 plus 35, so this is silver and this is chlorine, just taken straight from the periodic table. That gives us a mass of 143.25. Now I'm just going to have to grab a calculator in order to do this last little bit, because I can't do this in my head, but I'm going to put 0.005 and multiply that by 143.25, and that's going to give me my final answer. So it's going to be number of moles multiplied by the molar mass, which in this case is going to be 0.005 times 143.25, and I have 0.72 grams. So my precipitate of silver chloride should be 0.72 grams, and that's your answer. Thanks for watching.